Okay, let's take one more example. And what we have here is that we have this mass which is traveling at 20 meters per second, and it has mass of 2 kilograms, and somewhere here it encounters a rough surface. Here there is no friction, but here it encounters a surface with friction, and it crosses it and hits a spring which has a spring constant K equals 100 Newton per meter. Now the question is, how much does the spring gets compressed? Okay, very much similar to the last example. Let's start with how much energy we start with. Well, all the energy initially is kinetic energy, and which is given as half mv squared, which is going to be half multiplied by 2 multiplied by 400, which is 400 joules. And how much energy does the friction eats up? Well, we know work done by friction is F times D, but with a minus sign, and F is the force of friction, which we know is mu n, where n is mg, because the mass is lying on a surface. So if you make a free body diagram in the y direction, given this is x, this is y, then we know n is same as mg, and n equals mg anyway, times d minus, and this is minus 0.2 multiplied by 2 multiplied by, let's take g to be 10, multiplied by 2, and that gives us minus 8. Okay, so we started with 400 and we lost 8 because of friction, so that gives us 400 minus 8 equals 392 joules. So somewhere here the object has 392 joules of energy, and all the energy is kinetic energy. But when it hits the spring, what happens? It compresses it, and in the process of compressing it, it loses its velocity or the kinetic energy, and all the kinetic energy is transformed to the spring potential energy. Again, now it's straightforward. We know the spring potential energy is half kx squared, and which should be same as 392, where x is the compression in the spring. So x squared equals 392 multiplied by 2 divided by 100, and x is square root of 392 multiplied by 2 divided by 100. You can find it using your calculator. So that is the compression in the spring.